Hey everybody, it's Mr. Carr again. Today we're going to be starting Unit 8 on trigonometry. Okay, so 12.1 is going to be just kind of a brief review of our trigonometric functions with a little bit extra. Okay, so these are our basic ones you probably would have learned in the past. Sine, cosine, tangent. Okay, as a refresher, those are opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, so you can see here for sine, cosine, tangent for our angle theta here, and that's opposite, adjacent, hypotenuse. So the sine is 4/5, cosine is 3/5, and tangent is 4/3. Okay, three new ones are what's called the reciprocal ones. Reciprocal trigonomic, sorry, it's reciprocal trig ratios, and that is cosecant, secant, and cotangent. You see how they're uh, abbreviated as CSC, SEC, and COT. They're called the reciprocal ones because if you notice, we have opposite over hypotenuse here, hypotenuse over opposite, adjacent over hypotenuse, hypotenuse over adjacent, and opposite over adjacent, adjacent over opposite. So we're getting reciprocals of each of these. And so in fact, cosecant is the same as 1 over the sine of theta. Secant is 1 over the cosine of theta, and cotangent is 1 over the tangent of theta. Okay, so that's why when you look at down here, these are all reciprocals of the one above them. So sine goes to cosecant, cosine goes to secant, and then tangent goes to cotangent. Okay, so that's all we're looking at for these new ones here. They are reciprocals of our main three that we've covered, that you would have covered in previous classes. Okay, so what we're going to look at here for our trigonometric functions, we want to find all 6 for angle G. Okay, so for angle G, I'm going to mark that one. For my process, I like to label opposite, adjacent, hypotenuse to angle theta. I start with the hypotenuse because that's the one that's always going to be the longest side and it's across the right angle. Okay, and then we can go across from that angle here to get to the opposite side. And then I like to think of the adjacent side as the one that is attached. Okay, it's attached to the angle and it's not the hypotenuse. Okay, so I just put an extra C in there. Let's take care of that. There we go. Okay, so adjacent, attached. That's how I like to think of that one. So if I set up my first three, I'll do sine of G, cosine of G, and tangent of G. Okay, so sine of G is going to be opposite over hypotenuse. So in this case, it's going to be 24 over 40. Okay, if I reduce that down, I can divide all that by 8, so I get 3/5. Cosine of G is going to be the adjacent 32 divided by the hypotenuse of 40. And again, if I divide both the numerator and denominator by 8, I can get it down to 4/5. And the last one is the tangent of G. Now that's going to be opposite 24 divided by the adjacent 32. So that's 20, divide both of those by 8, and I get 3/4. Okay. Now, when I do my reciprocal versions, sine, it's going to be easiest to do cosecant. The cosecant of G, that is the reciprocal of sine. So I just know it's going to be 5/3. Just flip the 3/5. I don't have to worry about the 40 over 24. Okay. Cosine will go to, secant of G. So that's going to be 5 over 4. Okay. And then the tangent of G will go to cotangent of G. So that has a reciprocal of 4/3. All right. That's it. That's all 6 of them from there. All right. So now we can zoom out a little bit here. In a right triangle, angle A is an acute and tangent of A is 5/3. Find the value of the cosecant of A. So when looking through these problems, what I like to do is I like to think about what is cosecant the reciprocal of, and then use that to help me find what I need. So first thing is, I know that cosecant is 1 over the sine of A. Okay, so since sine of A, if I were to find that, is the opposite over hypotenuse, that means that the cosecant of A would be the hypotenuse over the opposite. So when I look at this, here's angle A. I'll mark that angle. Opposite is here. 3 is adjacent, C is hypotenuse. So I'm missing the hypotenuse in this scenario. But I can find it. We have a right triangle, we could do Pythagorean theorem. So I'll do that first. I'll do 3 squared plus 5 squared equals C squared. Okay, so 9 plus 25 equals C squared. 34 is equal to C squared, and then I could square root that to get to C. So that means when I do the cosecant of A, that is the hypotenuse, the square root of 34, divided by the opposite side, which is 5. Okay, so again, when thinking about this, first thing I want to think about is it's a reciprocal of sine. So if sine is opposite over hypotenuse, then I'll switch it over to hypotenuse over opposite, which means I needed to find the hypotenuse then. All right. So another thing we want to look at is our special right triangles. So 30, 60, 90, we follow this pattern of x, 2x, and x root 3. Now, you may want to, for our purposes here, when we deal with our trigonometry, instead of doing it as x, 2x, and x root 3, we might want to do it this way, which is just putting their numbers down. So across the 30s, the smallest side is 1. The longest side is actually 2, and that's across the right angle. And then root 3 is across the 60. The 45, 45, 90s, a little bit straightforward. Okay, so this has another name of isosceles right triangles, which means we have two sides that are going to be the same. This is isosceles, and that's 1, 1, and root 2. So from this, we can actually use, potentially we can use some of these ratios here. So the sine of 30 is opposite divided by hypotenuse. So I'll look this way, opposite divided by hypotenuse. Okay, so that's 1 over 2. Okay, the cosine of 30 is adjacent divided by hypotenuse, so it's root 3 over 2. And the tangent is opposite over adjacent, so that's 1 over root 3, but then we can rationalize it to turn into that, root 3 over 3. Okay, so as a brief reminder, I can write it as 1 over root 3, but then I multiply both numerator and denominator by root 3, so that becomes root 3 over 3. So that's where this comes from. Okay. Now, one thing I want to point out here is sine and cosine of those complementary angles are the same. Happens there and there. They're always going to match up like that. The tangent of those complementary angles is actually just the reciprocal. So if I started with 1 over root 3 was the tangent, that means the tangent of 60 is actually flip that over as root 3 over 1. So those are going to be reciprocals of each other. Okay. When we look at sine, we got opposite over hypotenuse. Same thing as before. Opposite over hypotenuse is 1 over root 2. 1 over root 2 becomes root 2 over 2 when I rationalize it. So we multiply by root 2 and root 2 like that. Okay. Now we potentially can use those like this right here. I'm going to do this problem twice. Here's how we've done it before with our trig. So we want to use a trigonometric function to find the value of x. Round to the nearest tenth if necessary. So my angle is 60. I'm going to label opposite adjacent hypotenuse. So here's my hypotenuse. Here's my opposite side. Here's my adjacent side. I'm going to identify which trig ratio I want to use. I know the hypotenuse. I'm looking for opposite. So I'm going to use sine. The sine of 60 is equal to the opposite side x divided by 12. So option 1 for solving this is we solve this as kind of like a cross multiplication problem. I can take 12 multiplied to sine 60. So 12 times the sine of 60, and that equals x. So I just plug that in my calculator right now. So 12 times sine of 60, and that's going to come out as 10.39. Okay, and I should say right there. And I should say this, because it does say round to the nearest tenth, it's actually 10.4. This is option 1. That's using our trig in our values there. Option 2, I have a reference triangle. I've got a 30, 60, 90. So again, if I write that out real quick, 30, 60, 90, we got 1, 2, and root 3. Again, I am going to use sine because it's opposite hypotenuse that I'm working with. So from the 60, opposite is root 3, hypotenuse is 2. So that means the sine of 60, according to my reference triangle, is the square root of 3 over 2. Well, what that means is this ratio of root 3 over 2 is the same as this ratio, x over 12. If sine 60 equals x over 12 and sine 60 equals root 3 over 2, then that means I should be able to do this. So instead of using my calculator, I should say my trig in my calculator, I can just do this process. Okay, well, and actually, instead of cross multiplying, I'm actually just multiply both sides by 12 over 1. Okay, that will actually cancel that out. Divide by 2 is 1, divide by 2 is 6. So I get 6 root 3 equals x. And when I plug that in my calculator, I get 10.4. Okay, either option works. So it's just a matter of if you want to use the ratios with our reference triangles, just got to recognize that it has to be a special right triangle. So like a 30, 60, 90 or a 45, 45, 90. Then you can kind of go back to this idea. Okay, which one of these we can set up. And that can help us with our cross multiplication. All right. Last thing we can cover with this one is if we can't use, we'll still use our trig. If we don't have a special right triangle, we'll just do our normal trig in our calculator. So to calculate the height of a building, Joel walked 200 feet from the base of the building and used an inclinometer to measure the angle from his eye to the top of the building. The angle produced was 76 degrees. If Joel's eye level is at 6 feet, what is the distance from the top of the building to Joel's eye? So that's, according to the diagram, we're looking for this distance, which is kind of weird because it says to calculate the height of the building. That's a separate question from this, but we'll just focus on this question right now. So if I want to set this up again, we look at 76 degrees. Let's label everything we know. This needs to be hypotenuse. This will be opposite, and then this will be adjacent. I know the adjacent. I'm looking for hypotenuse. So I can set that up with cosine. Cosine of 76 is equal to the adjacent 200 divided by d. Okay, so if I make that over 1, we'll go ahead and cross multiply here because d cosine 76 equals 200. Gets a little bit weird, but we're going to divide both sides by cosine 76. So what that gives me is this. D is equal to 200 divided by cosine 76. That's what needs to go in my calculator. Okay, so we got 200 divided by the cosine of 76. And that's going to come out to approximately 826.71 feet. So that is the distance from the top of the building straight to Joel's eyes right there. Okay, so again, that's our basic trig. We use it to find missing side lengths. That is as far as we need to go for that one today. We'll continue with our 12 in day 2 for our 12.1, looking at a little bit more with our trig parts. All right, that's it for today. Take care.